Okay, welcome America, welcome Justin Bieger, thanks for coming back. Okay, so today we are solving equations with a change of base formula for logarithms. We've already done a couple problems. We have number 7 done here. We are going to do number 8 and number 10, and all these solutions and this worksheet will be attached. So let's go ahead and start. Number 8. Okay, so we take a look at number 8 and we see, just like number 7, that we have two different bases. Okay, so we can't just set, if the bases were the same, if it was log base 4 of x equals log base 4 of 2x plus 15, then we could just set x equal to 2x plus 15, but these bases are different. So I need to make the bases the same and then manipulate and solve for x and see if we have any extraneous solutions. So let's go ahead and use the change of base formula. I'm going to choose to do a change of base formula on this 16 and make this base of 4 because the left side base is a 4. So I'm going to make this base of 4. So they're the same. So leaving the left side the same, log base 4 of x equals, and we're choosing a log base 4 of 2x plus, that's a 2, 2x plus 15. Y'all, it's May. You know what that means? They told me I was getting my smartboard in May. Log base 4 of the original base, which is 16. So that's a 2x plus 15. And we're just following the change of base formula. You can Google that if you'd like. Okay, but it's in our notes and in the video that you watched last night for homework. So now what we've done here is this denominator is just a number. 4 to the what power equals 16, because that's what that equals. 2. So log base 4 of 16 is just 2. So I'm going to rewrite this with the 2 in the denominator here. Now I'm going to go ahead and multiply both sides by this 2. Get it out of the denominator there. Those are going to cancel. This 2 is going to go in front here. Using our log properties, I can take this coefficient and I can move it up to an exponent. In doing so, we have log base 4 of something equals log base 4 of something else. So those somethings will equal each other. So let's do that. So log, I'm going to move that 2 leading coefficient up to my exponent. So all I've done here is take this 2 and move it up. And I'm going to rewrite the other side, no changes. So now I can set x squared equal to 2x plus 15. And now this is just algebra 2. Throw everything to one side. Hope it factors. X minus 5, x is it plus 3. So we should have two solutions, x equals 5 and x equals negative 3. However, extraneous, and here's why. So here's our answer, x equals 5. Okay, if you look back up at the original problem, and just like we did for this problem, we took our 2, we plugged it in to make sure it worked. Okay, if we take this negative 3 and we plug it up here in for this x, 4 to the what power equals a negative 3? Think about that for a second. So if I take 4 and I put it to squared or cubed, or if I keep increasing those values and make the exponent larger and larger, I'm not going to get a negative number. What if I started making them negative values? Negative 1, negative 2, negative 3, negative 4. I'm going to end up with fractions. I'm never going to have a negative 3. So this negative 3 is not going to be a solution. So it's just x equals 5. And that is number 8. And I'm gonna also do one more problem. Oh, you're gonna love this. It's gonna be lit. Okay. Anyone have, is anyone still writing this down? All right, moving on to number 10. Okay, so first, using log properties, I can multiply the 5x and the x minus 1 and write that as 1 log. So in blue, the natural log of, and this is just log properties, okay, 5x times x minus 1, close parentheses, equals 2. Now, that natural log is the same thing as if I had written log base e. Let me write that. No one's ever going to write this, but this is what it is. Okay, so I'm going to erase that in just a second. But this is what you're thinking when you get a problem like this. E squared equals 5x times x minus 1. So I'm going to rewrite this logarithm in exponential form. So it's going to be e squared equals, and then I'm just going to distribute this 5x. So 5x squared minus 5x. Don't forget to distribute the 5x to the x and the 5x to the minus 1 for 5x squared minus 5x. Everybody good with the 5x squared minus 5x? Okay, let me throw everything to the same side. I'm going to move the e over to the right just to keep my leading coefficient for x squared positive. Oh, yay! Guess what? Anybody know what we're going to have to do?
Jonathan.
Tell me, Jonathan.
I'm afraid I might be wrong. Yeah, I was wrong.
You don't know. You could be right. This isn't going to factor. What do we have to do if it doesn't factor?
I was right. I was right.
Pythagorean theorem.
Pythagorean theorem is for right
I
triangles.
mean the what should I call it?
Yeah, I know what you're thinking. That's it. Okay, yeah. So, negative b. So that's going to be positive 5 plus or minus b squared. Anytime you have b squared, whether b is positive or negative, b squared is going to be positive because a negative times a negative is a positive. So, b squared minus 4a c. That's an e. There we go. All over 2a. Let's simplify that. That's going to be x equals 5 plus or minus square root of, what is that, 25 plus 20e squared all over 10. So then you just take out your calculator. You type that in. And here are the two values you will get on the graphing calculator. And these are rounded, so they're approximately 1.814 and approximately negative 0.814. What are you guys going to use for a calculator? Are you going to use the, do any of you have an Android? You're going to use the Wabbit Emu app? Raise your hand. Anyone using that? Okay, anyone using a handheld that they already have from home? Okay, anyone going to use these graphing calculators they have up here? Okay, what are the other options? Does anyone have a graphing calculator app that I'm unaware of?
Can you use Desmos?
You can. Yeah, yeah. It's just when I'm giving directions for the TI-84, it's just different on Desmos. Okay, so we've got an extraneous solution here. And really, all you've got to do is just be careful when you throw these values in. You'll see that you're going to end up with a negative. inside here. And remember, the last problem, 4 to the what power equals -3. Couldn't find anything. Same for this one. So just throw the numbers back in and make sure you get a value. And this one doesn't work, so that's an extraneous solution. So there we go. And I think I am finished recording. Anyone have a shout out or any announcements we need to make?
Come see Anastasia.
Come see Anastasia. Are we having a Thursday show this week or no?
Friday and Saturday. Friday at 7 p.m., Saturday at 2, and Saturday at 7.
Boom. Okay. Ryan, when's the next baseball game?
Thursday, senior night.
Senior night, Thursday night. Is it home?
Yeah.
Who are we playing?
Rockridge.
Rockridge. Are they any good? Excellent. All right. Oh, peace out.